Okay, so this part I will continue on an equivalent circuit of the transformer. So from this figure 2.3, so this is actually the real model of the transformer. So what we have here, this side is the primary side of the transformer. So we have here is primary voltage, primary current, equivalent parameter for the primary. Okay, and what we have here is the RC and SM, which is this is the magnetizing parameter, and this is the secondary part of the transformer, so which this side will be connected to the load. Alright. Okay, so what we have here is the V secondary or secondary voltage, and then we have secondary current, and we have the equivalent parameter for the secondary. And this one is number of primary for number of the primary turns, and this one is number for the secondary turns. Okay, if you look at this sentence, the figure shows the accurate model of the transformer, but it is quite difficult to analyze practical circuits containing transformer. Thus, the equivalent circuit normally has converted to the equivalent circuit at a single voltage level. So, therefore, the equivalent circuit must be referred either to its primary side or to its secondary sides. Alright. So next. So this is the model for the primary referred to its voltage, and this one model referred to its secondary voltage. So what you can see, the difference between these two model. Okay, if you look at the primary side, okay, so at the primary side, both primary side, okay, both primary side. Okay, for the model referred to the primary voltage, this one is maintained for the V primary, and this one maintained at the I primary, and also this one maintained at RP and XP, also goes to the RC and SM. Nothing changed. Alright, but when it comes to the model referred to secondary voltage, your voltage at the primary become VP over A, IP times A, and both equivalent primary divided by A squared, and also for the RC and XM also divided by A squared. Okay, so this is the comparison between referred to primary voltage and referred to the secondary voltage. Okay, you can see the difference in terms of VP, okay, equivalent parameter. Alright, so next for the secondary side. Okay, for the secondary side, okay, so this one is AVS for the model referred to primary. A times with the A, current IS divided by A, and then for this secondary voltage, this is maintained at VS, this is also maintained at IS, and this one maintained RS and XS. Okay, and this one you have to convert all this value. Okay, equivalent parameter, you have to divide by you have to time with the A squared. Okay, this one IS over A, and this one A times with VS. Alright, so next, the excitation branch, has a very small current compared to the load current of the transformer. So moreover, it is so small that under normal circumstances, it causes a completely negligible voltage drop in RP and XP. Thus, it can be simplified into approximate equivalent circuit. Alright, so this is the primary side, and this is referred to the secondary side. Okay, so as I explained before, look at the primary side. Okay, VP maintain, IP maintain. Okay, so IS divided by A, VS time with the A, and this is the R equivalent and S equivalent, which is you have to times with the A squared. Okay, so this is the formula to get the R equivalent circuit and X equivalent circuit referred to the primary side. And this one referred to the secondary side. Value for VS, value for IS, maintain. Alright, and then however, this one VP, you have to divide by A. Primary current you need to times with the A, and RC XM also divide by A squared. Okay, next, this is when there is no RC and SM, so you have only this equivalent parameter. This is you only can see this circuit without excitation branch. Okay, referred to the primary side. Okay, when we talk about primary side, okay, all value for the parameter maintain. VP, IP, R equivalent primary, S equivalent primary. Okay, however, for the secondary side, VS times with the A, IS divided by A. Okay, next refer to the secondary side. VP pula you akan divide by A, IP you times dengan A, VS maintain, IS maintain. Alright. So, next 3.0. Okay, determine the value of component in the transformer model. Okay, there are two types. Okay, there are two tests that you can do to find the value of the component. Okay, the first one, you can use open circuit test and then short circuit test. Okay, you have two tests to find the components in the transformer model. Okay, for the open circuit test, you will get value of RC and XM. Okay, so the value of RC and XM can be determined by opening the output line at the secondary side of the transformer, as in figure below. So this is the primary side, okay, which is VP, and then this is the secondary side. Okay, this one is VS actually. Okay, so this side actually connected to the load. Okay, however, this output line will be open. So you put the ammeter here, okay, and then voltmeter here. You can get the value of. Then you also put the wattmeter here. Alright, so you can get parameters at this condition. P open circuit equals to V open circuit square divided by RC. So that RC you will get V open circuit square divided by P open circuit. So these two value you will get from the test. So you akan dapat value of RC. Alright, so once you get value of RC, you can get value of IC. Okay, IC equals to V open circuit divided by RC. Okay, if you need to find value of IM, so IM equals to this formula, where your Xm equals to this one. Okay, V open circuit divided by Im. So remember this one, P open circuit is core loss of the transformer. Okay, so P open circuit equals to this one, this formula. IC equals to this one. Im equals to this formula. Alright. This so you can use this formula IC and SM, okay, to get this lah. Okay. Next, short circuit. For the short circuit test, you will get value of R equivalent and X equivalent. Okay. So for short circuit test, the secondary terminal of the transformer are short circuit and the primary terminal are connected to a very low voltage source. So like this. So the secondary side is shorted. Okay, shorted. And then you put the ammeter here, you put the voltmeter here, you put the wattmeter here. Alright. So you can get value of R equivalent and X equivalent from this formula. Okay. Since you will have you will get value of P short circuit. Okay. So from P short circuit you will get value R equivalent equals to this one. R equivalent equals to P short circuit divided by I short circuit squared. So next, Z equivalent equals to this one, V short circuit divided by I short circuit. So you will get value of X equivalent from this formula, which is Z equivalent minus R equivalent. Okay, squared. Okay, square root of the square root of Z equivalent squared minus R equivalent squared. So you will get the X equivalent. Okay. So take note here, P short circuit is a copper loss. Alright? Copper loss. So settle from this short circuit test, you will get value of, remember you will get value of R equivalent and X equivalent. And then for the open circuit test, from open circuit test, you will get value of RC and XM. Okay, so you get value RC, you will get value, which is XM, this one, XM. Okay. Alright. So thank you. I will proceed for the transformer voltage regulation at next part. Alright. Thank you.